Hilchos Kiddush Hachodesh, Perek Yud Beis and Yud Gimel. This class is dedicated to the Refuah Shleima v'Elimelech Yitzchak ben Fega Mindel. In the last 9 prakim of Hilchos Kiddush Hachodesh, the Rambam lets us in on what he calls ibur, the complex computations used by Bezdin to determine whether or not the moon could be sighted on the night following the Moiled. Remember, we discussed in the last class, at the Moiled, the conjunction between the moon and the sun is only a moment in time. The second after the moon reaches the sun, it's already continuing on its path eastward, further away from the sun. So that at the next sunset, when the sun dips below the horizon, the moon, which has moved further east, for a window of time will still be visible in the sky. The question is, and this is what Bezdin had to figure out, did enough time elapse between the Moiled and that sunset for the moon to have achieved sufficient distance from the sun and sufficient prominence in size to actually be observed? Essentially, it would seem like the solution to this problem is pretty straightforward, pretty simple. We know how fast the sun travels in its orbit every day. It's 1 degree, about 1 degree. We know how fast the moon travels every day in its orbit. It's about 13 degrees. Well, just figure out at which degree is the sun on that sunset in its orbit, at which degree is the moon on that sunset in its orbit, what's the distance between the sun and the moon, and that'll give you your answer. If they're too close, then obviously in the short time between sunset and moonset, the moon won't be observed. If it's further out, well then possibly yes. But of course it's not that simple. Like everything, it can't be simple in Kiddush Hachodesh. The Rambam tells us that even after we calculate that information, we will only have achieved the מקום אמצעי, the mean or the average position of the sun and the moon on their orbit. In order to get to the מקום אמיתי, the true position of the sun and the moon, a number of compensations and corrections have to be made. What does this mean, true and average position? Why is the first position not true? And what exactly are these corrections? Well, that's the topic of Perek Yud Beis through Perek Yud Zayin of Hilchos Kiddush Hachodesh. Perek Yud Beis and Yud Gimel are the corrections for the sun's position. Perek Yud Daled through Perek Yud Zayin are corrections for the moon's position. And in order to understand these corrections and why that makes the position truer, let's go in order. In this class, we'll cover the corrections relevant to the sun. And the first thing to understand is actually pretty fundamental. And I'll try to explain it this way. Every circle, a number of times we've already said this, is made up of 360 degrees. Now, a degree is not a fixed amount of space, like an inch. A degree is proportional. It's proportional to the size of the circle. A bigger circle has bigger degrees. A smaller circle has smaller degrees. Each circle has 360 equal spaces. Hence, if you drew a circle within a circle, and then you put an object at a given point on the inner circle, let's just say for argument's sake, 20 degrees. If you would then proceed to draw a line from the center of the inner circle through that object at the 20 degree mark and cross it to the border of the outer circle, you would find, of course, that it would meet the outer circle also at 20 degrees. Because from the center of both circles have the degree points at the very same points on their border. But that's only true, of course, if the two circles were centered. What if the inner circle was off-centered? Well, then you discover that if you put an object on a given degree somewhere along the inner circle, it will not be seen at that same degree from somebody standing in the center of the outer circle. The easiest way to think about this is if you and your friend are standing 5 feet apart and someone comes to you on your right side with a ball and asks the two of you to tell him what you see behind the ball, each of you will describe vastly different things. Because each of you are the center of your own circle, the center of your own vantage point, and when you look out, you will see things behind the ball at a different angle. And guess what? The Rambam says the same thing applies to the sun and the moon. The outer circle, in our case, would be the Galgal HaMazolis. The center of the outer circle would be the Earth, which is in the center of everything. The sun and the moon, which spin between the Earth and the Galgal HaMazolis, their orbit is off-center relative to Earth. So that, when they are on a certain degree on their orbit, you on Earth looking out into the Galgal HaMazolis may not observe it at that same degree. Let's make this clear. Here's a diagram. You can see the Earth in the center. You can see the Galgal HaMazolis on the outside. you can see that the inner circle is the sun's orbit and that it's off-center. The center of that circle is not the Earth. Notice that because it's off-center, there's a point on the sun's orbit where it's closest to Earth, and there's a point on the orbit where it's furthest from Earth. The point where an off-centered circle is furthest from the center of the outer circle, or in our words, the point where the sun's orbit is furthest from the Earth is called the goiva, or apogee in English. And because it's off-center, wherever the sun might be on its own orbit will not be observed at that same degree when looking from Earth to the Galgal HaMazolis. For example, here you see the sun on its orbit at 30 degrees. Look out to the Galgal HaMazolis, draw a line from Earth through the sun to the Galgal HaMazolis, we will see it at 25 degrees. Let's move a little further. When the sun is at 60 degrees and the angle increases, now somebody looking from Earth will observe the sun at 50 degrees, 10 degrees behind its mean position. When the sun reaches 90 degrees, the angle is biggest. Now it will be observed somewhere around 75 degrees on the Galgal HaMazolis. That's almost a 15-degree difference. Then, when the sun passes 180 degrees, you'll notice instead of being observed as behind its mean position, it'll be observed as ahead of it, because the angle goes the other way. Of course, at 0 degrees and 180 degrees, there will be no difference, because the lines will cross. This difference caused by the off-centeredness of the sun's orbit is the first element of the difference between mahalach Eמצעי and mahalach Amitī, or מקום Eמצעי and מקום Amitī. The average or the mean position means the sun's position on its orbit relative to itself. The true position means where is the sun observed by the viewer on Earth on the backdrop of the Galgal HaMazolis. In Perek Yud Gimel, the Rambam does the work for us. He gives us the table. He says, all you have to know is where is the sun on its own orbit, and I will tell you how much to subtract or how much to add to reach the sun's true position. Now, there's one more factor that has to be considered, and that is that the sun's orbit is not only off-center, but it's also moving. In other words, the goiva, the apogee, the point at which the sun's orbit is furthest from Earth, is itself changing and fluctuating. Very slowly, moves about 1 degree every 70 years, but nevertheless, it's moving. And so, it's not like the sun's orbit is stationary in an off-centered place, and one could then say, all right, whenever the sun is at 30 degrees, we know the correction, 50 degrees, we know the correction, etc. We first have to determine where is the goiva. We first have to determine where is the apogee. Then we can determine the distance that the sun traveled from its apogee, and then apply the corrections given to us in Perek Yud Gimel. That's what the Rambam calls the maslul hashemesh and the menas hamaslul. That's the path that the sun has traveled on its orbit relative to its goiva, and then you require the menas hamaslul, which is the angular distance, the angular compensation really, to bring us to knowing where the makam amiti of the sun is.